All right, here we have a question on the pH of a sodium oxide solution, and we are given its concentration. And the thing that you need to remember about Na2O or anything with an oxide, remember, is we're putting O2 minus into solution. That's our oxide. Okay, when Na2O dissolves into water, so we're going to put it, and I should probably have specified that this is aqueous. See, this is why we write the exams as a group so that all of my little tiny mistakes are caught. And we read anyways. Na2O, when it goes into solution, aqueous solution, it is going to dissolve into 2Na plus and O2 minus. O2 minus is a really strong base. It is not going to just sit there. It's a lot of a negative charge to put on one atom. So very quickly, O2 minus in solution, in aqueous solution, is going to, and I'm not even going to do, I'm going to do, it's a strong base. Okay, so this is going to use its extra electrons to grab a proton from water. Okay, so when it does that, it pulls a proton off of water, which makes HO minus, why I wrote it like that, OH minus, a hydroxide anion. But importantly, once it takes that proton from water, it leaves behind another OH minus. All right, so that means every unit of sodium oxide that goes into solution generates 2 OH minuses. And that's what we need to know. We need to know the OH minus concentration so that we can calculate the pH. Okay, so we put in 0.0045 molar of sodium oxide, which means we are going to get, so in other words, the chemistry that I'm doing here is I say 0.0045 molar of Na2O. I know that for every 1 mole of Na2O, I'm generating 2 moles of OH minus. Okay, so that's, now I know that I have 0.009 molar of OH minus in solution. Okay, that's now what I can use to calculate the pH. Okay, so now this time I'm going to do OH minus times H plus is, and again, this was at room temp. Okay, that means Kw equals 10 to the minus 14th. Okay, so so OH minus times H plus equals 10 to the minus 14th. Now I know that my OH minus concentration is 0.009 molar. And again, this is activities because this is an equilibrium expression. So I can solve out for H plus because I need H plus to calculate the pH. That's 1.11 times 10 to the negative 12th. Now I can take the pH as the negative log of H plus, which equals the negative log of 1.11 times 10 to the negative 12th. That's 11.95. That's what I'm going to put in here. And then I'm going to stop and ask myself, does that make sense? I put in sodium oxide, that's a strong base, and I wound up with a pH much higher than 7, so it's a basic solution, and that tracks. That makes logical sense. I put in a base, I have a basic solution.